We only have 45 minutes to solve sharing data, so we should probably get started. I think that what we were going to do is kind of start with just letting Megan talk a little bit about her experiences at the library, since she didn't get to do the spiel like I did. And then we can open it up for, and I'll talk a little bit about some of the experiences that I've had around this, and then we'll open it up for interesting discussions around some of the questions that we mentioned in the presentation. So.
Okay. Guys, can you guys all hear me okay? All right. Thank you for nodding. As a frequent teacher of classes and public speaker, I always look for the nodders and then just stare at you through my whole presentation. So I'm Megan Laurance. I'm a molecular and cellular biologist by training. Relatively new, I would say, still to the library world. I started at UCSF. It'll be 3 years in February. As the research informationist, which is still a relatively new position in libraries, but the UCSF library hired me to basically design and implement some new data-centric services or basic researcher-centric services. And so my role is really split between two different areas, providing bioinformatics services, making sure people know about resources for learning more about bioinformatics methods and applying them, and also databases. And then also data management, which is a smaller piece of what I do, but they're actually kind of really closely tied together. Prior to coming to UCSF, I was at a software company that was building software for the analysis of genomic data, so whole genome-wide expression data. And so that's really kind of what I want to talk about today, and where a lot of my perspective is coming from today about data sharing, in that I have been a beneficiary of open genomic data for the last, 12 and now 3 more years, 15 years, without really knowing much about how all that data got there and what the policy was until I took on this role at the library. So I am a huge proponent of open data, in the sense that I like talking about data reuse and how much value there is in these huge repositories of public genomic data. I'm really interested to hear, hopefully from you guys today, about other data reuse use cases out there. Are there things analogous to the open genomic data repositories where data reuse is really catching on? So for me, again, after doing software development for 12 years, we didn't have any wet labs. In order to train our algorithms and train the software and design solutions, we needed a pool of data, and open genomic data absolutely helps with development of new software tools and algorithms and methods. I'm a beneficiary of open data in 2 other components of my job. So a lot of my time is essentially paid for by the library, but I'm also, part of my time is dedicated to the Genomic Medicine Initiative at UC San Francisco, where it's my job to curate knowledge around genetic variants with respect to whether they're causally connected to the phenotypes that we're studying. My ability to do that is completely fueled by the fact that there are databases like ClinVar and publicly available databases, again, of genetic information that's submitter deposited. People are willingly sharing this data, including genetic testing companies, which is very interesting to me. There's a lot of kind of general agreement that if we're all going to start doing this business of whole genome sequencing and whole exome sequencing for better diagnosis of disease and better decisions about which treatments to give, that we all have to be a little bit willing to share our data, or it'll take a lot longer to get to the right answer. So again, just my perspective is really coming from someone who's benefited from open data for quite some time. There's another small piece of me that belongs to a biomarker project searching for novel biomarkers for an autoimmune disorder, and I utilize publicly available data to fish for candidates for that as well. So as someone who's benefiting directly from open data, my role as the research informationist, it's part of what I do and should do to teach the value of open data to researchers as a way to kind of get across the value of open data, and that it's I'm really focused on stressing the value of open data, data sharing, not as the end of life part of the research cycle, which is where it's frequently talked about. Okay, study is over, I have to comply with this policy, I have to put it in a repository. That's certainly something that we want to help with, but I want to make sure people understand that the open data is part of the discovery phase of the research cycle as well. Right up front, when researchers are looking for prior established knowledge about whatever they're studying, to go beyond just thinking about the literature, but the underlying data as a source for discovery as well. That's just a little bit of perspective on open data. So again, I teach these workshops. They're open to everybody. Postdocs are the largest group of people that attend the workshops, but I also get research staff, faculty, and it's also been picked up into the grad student curriculum as part of a kind of a computational biology series, and that gives me a chance to sneak in the policy part, which shockingly people are appreciative of and interested in. So that's a little bit of perspective on my involvement in open data. My goal for this discussion, and we're really hoping it's going to be a discussion, is what's happening in other data disciplines, other fields. Again, reuse is what I'm focusing on, but the reality is that a lot of the data that's out there, open genomic data, came because of a really strong need to encourage reproducibility. That stemmed from some fraudulent situations that came up with some genomic data. So what's happening in other fields? What tools are you guys all using? And I think when we start asking questions, one of the things we're interested in is, are there any researchers in the room? Or are we all part of the people who are in information services and libraries? I'm just curious who else is in the room.
We can ask that now.
Can we ask that now? So are there any researchers in the room? Yay!
All right, so we're now going to interview you for the next 15 minutes. Yeah, I don't think that I have too much to add. I think I've kind of said what I wanted to say. My experiences at CDL when I was there involved a lot of outreach and education around data sharing, which of course means that you have to be able to manage your data well to be able to get it out there in the first place. And so the big challenge is getting people to think about it at the beginning of the project, which I think is what Megan was kind of hitting on. And how do you get them to think about it at the beginning, and what tools do you suggest that they should use to kind of make things easier for them? So maybe one of the questions I'd like to ask is if anybody here has been had some sort of experiences with data sharing on their campus, or interactions with researchers that were interested in sharing their data, or complying with policies in some way, and if somebody's willing to tell us about it, any anecdotes.
I mean, I can blather on forever about our experiences. We're also Dash users, the Dash service, we call it Data Share at UCSF, so, but we really want to hear from what you guys, yeah, go ahead.
I guess one thing I'll type in as a researcher, I think that there's one of the neat things that's happening on campus, and it bids is this Jupyter notebook thing, which I think you're supporting, right? But that's just, I basically want to sort of speak to the fact that there are lots of different types of data that should all be open, right? So I don't know much about this genomics data archive. I know about ones in my field that are for a very specific type of data, right? Where people want to be able to get it in the same form so they can do cool stuff with it. Mm-hmm. But there are lots of other types of sort of small data that aren't going to fit some nice model, and there's also the data analysis that went with it in terms of reproducibility. So I just think it's important when people are thinking about how to sort of, if we really want to be sort of fully archiving the full life cycle of research, you sort of needs to be in a structure that isn't that sort of like prescribed. And you know, an example of where that happens, and you can do that right now, talking with Raymond about this at lunch, is a place like GitHub, where you can have a really easily accessible directory structure with readmes and things like that. And I think, you know, it'd be ideal if something like Dash can do that, where you have a really nicely sort of, you can navigate through directories, you can see stuff without having things to be like, this is a single file that's archived, instead of this sort of suite of data and code and writing about that's all in one place.
So the data repository I use quite a bit is the Gene Expression Omnibus, and one of the reasons, so there's an entire ecosystem that has developed around this. There are companies that have formed from reanalyzing the data and representing it out. And from my perspective, one of the things that makes it such a valuable database is there are standards for depositing, that metadata standards that include, so there's a couple things wrong with it, but they don't use controlled vocabularies around phenotypes and stuff, so you still have to do a little work to find what you're looking for. But you have to describe everything about how the data was generated, what software was used to get from point A to point B. You have to deposit the raw stuff and the normalized stuff, and it just makes it a lot easier to get in there and reuse it. So
I guess my point is I think
Yeah.
it's important to have those standardized data structures.
Yeah.
But I also think it's important to have ways to archive things that are messier.
Yes.
As
Yeah.
part of, because anyway, I just think both of those things have to be happening. Because if you want people who are developing a new type of data that doesn't fit some standards,
Yeah.
be able to, just to make it sort of reproducible.
So I also want to comment on, Carly, your point about introducing the process as early in the research project as possible and how hard that is. So right now, this biomarker project that I'm working on, the part that I'm avoiding is that another part of my job is taking the data and putting it into a proteomics repository. But all this data was generated before I got there, and so I have to backtrack. So I'm really interested in hearing if there are, what tools people are using. So the analogy that I am working with a company right now that's piloting something, and it's going to be free for researchers, and their analogy is I'm essentially going to be embarking on a travel log. So this is where I was, and this is how we got there, and what I really should be doing is creating a travel plan or an itinerary. Is there anything out there that people are using for that part of it?
Yeah.
Yeah.
Jupyter Notebooks is definitely a really good option for this type of thing. And I think when I say sharing data, I really, in my head, in my rainbow brain, I'm like, yay, I actually mean sharing everything that you need to reproduce the results in a paper, right? But logistically, nobody does that. It's really hard. IPython notebooks and Jupyter are as close as people seem to be getting right now, which is really cool. So IPython notebooks is a project that was started by a man named Fernando Perez, who's here at UC Berkeley, and now he's at Lawrence Berkeley Lab. And it's now transitioned to being Jupyter notebooks, JUPYTER notebooks, and that's for Julia and Python notebooks. And so Julia is another programming language that a lot of scientists are starting to use. And so the interesting thing about these notebooks is that they're essentially kind of in real time. You can compute things and see the results pop out just below where you've entered your code. And so they can be packaged very nicely and archived so that people can open them up and see exactly what code was used, and they can even plug in their own stuff and rerun the code and see what changes. And so it's a really good way to capture an entire process for a project. And there's a lot of use in the data science community of Jupyter notebooks just for this very thing, and for being able to reproduce results, because essentially you now have a script that you can visualize that helps walk you through the process. And there's, you can have graphs in there, and you can reconfigure the graph. Anyway, so it's a really good option for ensuring reproducibility, and it's very much not just about data in that case. It's about the entire end-to-end workflow and making sure that you can capture all of the details that went into that particular result.
Are there particular disciplines that Jupyter works better for, or?
Any Python script. I mean, if you're using Python, you should be using Python notebooks to document your stuff. That's.
And there's very few programming languages that there isn't a kernel for. Their goals are bigger than you can.
Yeah, and they just got money to expand the support.
It also goes back to what you were saying about data that, it being in GitHub or something, and really just trying to model or work with CSV files, even just being able to have something to play around with information.
Yeah, so I mean, I guess in terms of on these notebooks, an example is I generally make these now, and they become the sort of you can actually output them as a PDF that's then like the supplemental material for a project. But you can have them sort of under version control and something like GitHub as you work on the project, and then make it available that way too. If you can. I guess on one sort of from a library point of view, like GitHub's this great resource right now, but Brandon and I were talking about, I want it so that in 20 years, the data and code that I'm sort of packaging in this, is also archived.
Well, and so this is like, there are these integrations between things like GitHub and Zenodo, right? Zenodo, the data repository that's based out of CERN, and they take, they basically will take a copy of your GitHub repository and archive it and give it a DOI. And other repositories are looking into the similar integrations with GitHub. So in Jupyter Notebooks, it's the same thing. You could archive the actual notebook in a repository, in the Dash repository, or or you could archive it, you could put it in GitHub and then archive some version of that, in Zenodo or somewhere else. So there's lots of possibilities, I think. Personally, I'm not super worried about the types of people that are using Jupyter Notebooks. They're already they kind of drank the Kool-Aid already. They're not the ones I'm super concerned about. I'm a little bit more concerned about the people that are still in Excel and still writing their papers with Word, and
Which is 90% of the people I work with.
exactly. So I think depending on the discipline, you're talking about the large majority of individuals.
Yeah, so I mean, we certainly have researchers who have bioinformaticians and programmers in their lab, but the majority of the people that I end up working with either use commercial software to get from raw to normalized data, or from normalized data to results, and so, or they outsourced it, and they were handed an Excel file, so creating that, not a big fan of the word because it just sounds so, I don't know what, but the Provenance Trail, it sounds so very formal, and but that's essentially what people need, and so there's not really, so I'm always looking for an easy tool that helps you create that workflow. I'm starting with this form of data, insert method X, the output was Y, that was the input for, method next one, and and I think in a super ideal world, the closer I get to finishing the project, or each of those stages would be hooked into, okay, if you're thinking about eventually putting this data in the PRIDE proteomics repository, this file should conform to these standards. That's kind of a pie in the sky thing. So, yeah.
Well, so I'm really glad that the conversation just emphasizes that open access is not just about that very end point after the project is done. It really starts with what you're doing during the life of your project. And here at Berkeley, we've just launched a research data management service, and it's a partnership between the library and the research IT group in the Office of the CIO. And the reason that's such a good partnership is that the library has been really thinking about data management planning and also about preservation and sharing. And in the IT world, we're thinking about the databases and the backing up and the storage services. So we're trying to cover that whole cycle. And what we're starting to find now that we've opened up our consulting service is that people really want advice. I mean, there are people who say, no, I can just do it myself and talk to me. But there's a lot of people out there, a lot of researchers who are asking simple questions like, how do I describe my data? I want it to be shareable. That sounds like the right thing to do, but somebody tell me how. What does this look like? And if you can give me some kind of tool that can make it easier, all the better. But please just tell me what am I required to do?
Can I ask about that? So are you finding that people are coming to you because of some kind of mandate from a journal or a funder, or are they literally just I think this is interesting, I want to be able to do this better for my research?
Well, I think it's both. I mean, I think the people who end up seeking us out, or really there's a lot of referrals from other people on campus. It's more people who they know they could do their research more effectively and efficiently if they only had some tools and some advice. So often it's really about improving the research process, not so much complying with some cost.
Well, and in some ways, I think it follows this. I mean, I'm working in Palo Alto now, so I have to bring up ridiculous marketing concepts related to tech companies. So I read a book recently that talked about the early adopters and the late adopters, and I think we're in this phase right now where the early adopters, the ones that are coming to you and saying, like, this is, if I'm gonna do this, I wanna do it right, they're really good targets for the library community to try and invest time in, because they are willing to put in the work. There isn't a clear incentive for them to do this right now, and if they're willing to do it, that's great. And, you know, being able to figure out ways to help them and, you know, working one-on-one with them if you need to, you know, just making it as easy as possible for them to kind of be the people that set the example for their field or for their discipline or for their lab group or for whatever. I think that would go a long way towards encouraging better practices in other groups, you know, getting on that other part of the curve and getting everybody to buy in.
The one place where the kind of policy or lack of clarity about policy is a big kind of force here is in sensitive data, human subjects. There are a lot of people who, it's just not clear to them what they should do and then how to do it. So that is a place where policy and frankly the law and regulation is making a lot of people quite nervous.
I'll add that I think, and I also work on the research data management program here at Berkeley, and you know, some of the consultations that I've been doing lately, I've really seen how important it is that as a community we really place emphasis on engaging with researchers early on in the research process. I worked with a graduate student recently who basically, because of inconsistencies in file names that were already being used in scripts, things had developed into a situation where it would have been really difficult to go back and change these file names, but it made it really difficult to archive these files. And you know, and I can imagine how difficult, if this data were to be shared, which it won't be, how difficult it would be for another researcher to then access and reuse that data. And I mean, so much heartache could have been avoided if we could have done some outreach earlier on. But you know, trying to create an environment where researchers approach you before something is wrong is really, really difficult. And I would love to hear a little bit from this group if anyone has some ideas about how to do that. I would be really interested to hear.
There's one good thing that's happening on that there are these workshops on campus through software carpentry and then also data carpentry. So I mean,
We found that too. Yeah.
so those are, I mean, anyway, that's places where people can get scared, but that's probably before they're meeting with UX to be good.
I think there's some interesting overlap between learning computational skills and version control and the types of things that software carpentry teaches, and being a good data manager and being able to share your data at the end of a project. Those are very tightly coupled, and I think we sometimes lose sight of that when we're talking to researchers as librarians, which I used to do. I can say that I had good success interacting with researchers on the UC campuses by essentially saying, I will help you with your data to graduate students. And the graduate students were like, oh, please, yes, come look at this terrible spreadsheet, I don't know what to do with it.
Yeah.
And I would sit and work with them, and
Yeah.
that makes a huge difference in that graduate student's experience, and it probably changes the way they do things moving forward. But then they, you know, it starts a little bit of a wave maybe in their lab where other people start to notice that maybe that is a good technique and they should do it too. So.
I completely agree. I think for me, we have to accept that people are working in Excel. I think Excel workshops would be great. I don't know how many times I've worked with people with genomic data who lose, 20 rows of data because the genes SEPT 1 through 10 get converted into a date, and then it's just lost. Really basic stuff, saving as and completely overriding and losing stuff, and I think an Excel class, I'm looking at Ariel because she's our second year NLM fellow and she's helping me fire up our data management services this year. I think that would go over really well. I think for us, the grad students are so protected, their time is so well protected, it's inserting into the process. Right now they get, it was the same when I was a graduate student, there was one 3-hour session within a 1 month class on ethics that covered how to keep a good notebook. That was it. Everything else was learned in the lab and you're completely on your own. So for us, it's making sure we can insert ourselves somewhere into their workflow.
I think that's one of the good things about the research data management, the library and research IT coming together, because we're trying to get everyone in the library to be, as part of that process, you know, when people are coming to them about, you know, where to find data, they can help them, you know, with the consulting and service guide and hopefully eventually workshops that we're planning on doing as well.
Yeah.
So, yeah, trying to make everybody who's touching, you know, in some way the research process is, as a help, you know, helper.
Yeah.
Well, Tim, I didn't raise my hand. So I'm from a librarian from the social sciences perspective, and as I expect you may know, the social sciences approach to this is really quite different in many respects, because you guys are really adopting years ahead in terms of making tools that you use to analyze data all open source and not proprietary, and sharing it. A lot of the social scientists are very proprietary, and they rely, first of all, overwhelmingly they use Stata, which is proprietary software, even though they do share the files. And there is a way of reproducing results in Stata. The file, you can actually recreate all the tables and the functions. And there are archives that exist in the social sciences that exist for a long time. There are databases, which are really caught on. I was wondering if you knew about these or you had experience with them, because the different archives and tools that you mentioned are completely alien to my experience. I was just wondering, it'd be really interesting to get you guys to talk a little bit more. I think you could both learn from each other.
Yeah, no, that's exactly why I'm interested in hearing from you guys. So I'm looking for the analogous situation where the pieces are there. So if the how the data was analyzed is there, maybe the original surveys are there, and the actual
Sometimes,
data is there.
Sometimes they are.
What's happening with that data? How did it get there? Are people reusing it? Is there value in revisiting that data?
Well, yeah, all the time.
Yeah.
I mean, I help just with grad students, undergrads, if they're trying to find a study, they want to find the results of it, we'll definitely reuse it. I mean, some of the social data files are so massive.
Yeah.
National longitudinal surveys, they can be
Right.
just the cows got home. So they've got maybe hundreds of variables. So that certainly exists. But at the same time, a lot of it is something that they really don't want to share. They're relying on it from commercial vendors that charge a lot of money.
Yeah, yeah.
It can be quite expensive. I mean, some of the databases that we subscribe to, that libraries subscribe to, can cost tens of thousands of dollars financially or firms that sell it.
Yeah.
It's quite different from your universe, but it's an interesting
Yeah,
alternative universe.
and I don't know who said it earlier in the day that because of NIH policy that we had solved the problem in biomedical data sharing. That's absolutely not the case. I would say that there is longstanding policy around genomic and genetic data that has made it, from my perspective, one of the examples of you can go to these repositories and do great studies on the data citation, open data citation advantage. But there are plenty of other researchers who aren't doing that type of work who are shocked to learn that they're applying for American Heart Association just changed their policy on open data, and people learning that they have to have a data sharing plan, and they never encountered this before. I just had a researcher who contacted the library because he was publishing in PLOS and was shocked to learn that he had to share his data. And I was like, well, you're publishing in an open access journal, but this was all, for certain types of data, the very long tail of different data types, the data sharing culture isn't quite there yet. So that's where a lot of the tools, so that's a place where Dash has really come in handy. It's really easy for people to deposit their data. And,
May I differ a little?
Yeah.
I mean, I've noticed, can you just tell me what's been the uptake at this campus, for example, with Dash?
Oh, I can't speak for Berkeley, but it's very slow at UCSF.
Yeah.
A couple comments on that. Part of it is the amount of outreach that we've done lately has been pretty low, but even when we do outreach, I would say that the biggest use case that is still driving data sharing is publishing, and Dash doesn't quite yet support that workflow I think they're working on it in the next release, which is to say people need to put their data in a place where the reviewers can look at it during the manuscript approval and review process, but not quite public, and then when it's published, then they make it public. So those, I mean, I think we're talking about an embargo feature, and I think they're working on it. I think for us at UCSF, and I can't speak for the other campuses, once that feature comes out, it then, I think, completely supports the share your data because the publisher requires it use case, which, again, in my experience, it's just my experience, is what's driving a lot of the data sharing.
May I press the point a little further?
Yeah.
For Dash, what are the requirements for a researcher, in terms of making positive data? Do you have any metadata requirements?
They're there, but they're pretty minimal. I think the required fields are minimal. I think people who are used to curating their own data sets and are very interested in data sharing from a data reuse and data discovery perspective are going to town and filling out the full methods, README files, all that stuff. People who are using Dash, data share at our campus, to comply with policy are doing the bare minimum. So I think if we want to, it's like, to me, it's like any other open data repository. If you want to encourage best practices around data curation, you have to show them what that
If you
means.
take a look at the data first files, again, like in the Harvard MIT,
Yeah.
they're beautiful. I mean, you go in there, you see description in a paragraph, it tells a casual researcher what the study's about. They will list the code book, they list the file, they say it's a data file, they'll have the data file, they'll have the
Right.
data file, they'll have all this stuff. It's really easy to use, and that's very helpful for like a typical undergrad, grad student who is not maybe in that field, is
Yeah.
understanding the terminology. And, to find out if the study is relevant to you, there may be hundreds of variables. You have to be able to read it,
Yeah.
figure out which ones are applicable. So,
Yeah.
like a little search box in there, that will help you find out. Otherwise you're stuck reading the code book.
Yeah.
It's very labor intensive.
Yeah.
So just to kind of take the conversation in a different direction, and I'm glad there are the researchers here, is thinking about the incentives for sharing
Yeah.
data. Really, why, I mean, to be a good scientific citizen, and really what drives people to share them? The organization I work for, DataCite, we create DOIs that enable data sharing, data citation. And so I'd be curious to know, what other people hear of why share your data, why manage your data, other than being a good citizen, and the carrots and sticks.
Well, I mean, one avenue that I've been looking into lately when I've talked to some library folks about how to sort of incentivize people to come to these workshops and learn about data sharing is that, I mean, it could potentially improve your H-index, which is increasingly becoming a requirement for tenure and promotion, which, I think that doesn't exactly it's no upheaval to the current publishing model, but I think that there's some potential there anyway. But, it's hard to think of those carrots, right?
Well, there is something really interesting that I know that I worked on while I was at CDL, and I worked on nutrition while I was at CDL, and it's this idea around kind of data publication. And it's essentially saying, like, it's not about just throwing your data out somewhere and saying it's available and complying and checking the box, but instead you actually can get a citation out of it that you can put on a CD that has a DOI that counts as something. I mean, it looks substantial, and it's a very small thing, right, to have a citation for a data set, but it can make a huge difference in terms of how a researcher perceives why they should share their data. And being able to publish the data either in a repository that gives it a DOI, Dash does that, or Bigshare or Zenodo, or you can actually publish data sets in journals that publish data sets. And if you really wanted to have it in an actual journal, you can do that. And so I found that researchers respond really well to that.
If I were a researcher who put data out there, I would want to know who's using it, who's downloading it, I'd love to hear if there's anything in the works out there, so that when you do, so I use data from Geo all the time, and there are no requirements other than general agreed upon norms. If that leads to a discovery and we publish on it, then you cite that record. But that's just because I've been doing it for a while and I kind of know what's expected in the field. It would be great if there was something that was either tracking, this data set's been downloaded 20 times by whatever, that it's not a restriction on data use, but at least, something that's like, what are you gonna use this for? And so that researchers, I don't even know if researchers can go to GEO and request, are there any metrics on my data sets?
Yeah, so I guess, I currently work for PLOS, and next week I'll be working for CDL.
Midnight on Sunday.
And we, PLOS and CDL and Data One worked on a grant from NSF.
That sounds really interesting. Was there anybody involved in that other than?
Yeah, Carly. Looking into exactly that, like what are the unique metrics around data, and how can they be tracked and shared across different disciplines? And I think when we were talking about incentives, obviously that's one big incentive is if you can show the reach, then there's then incentives to share, because then that's part of the whole ecosystem. But also just the carrot and the stick of the publisher itself. I mean, by promoting publishers that are having strict guidelines, you're then kind of getting more researchers into the habits and understanding what the possibilities are. And so publishing at places like PLOS changed the communities that it touches.
Yeah.
Right, and one of the, just to really quickly to add on to what John said, is that at DataSite, we're implementing that piece now where when you do a search, you can see, oh, this was cited by, if you have a data set, then you can see the kind of the impact of that downstream. And our colleague at CDL did some research about what people really want to, they don't want to necessarily see social media citations to their data, but they want to see real, in a journal article, et cetera. So I think those are the kind of incentives that I hope the community will think, oh, this is.
So BioGPS is another public gene expression database that reuses all the geodata. So that's never going to result in another citation. But I'm hugely benefiting from that data set. Goes out to like 6 different other added value repositories. Are they required to say how often they download? I mean, that's reach on those data sets. I feel like they should be getting credit for that somehow. Sorry.
So I worked at PLOS One, and it's funny that this brought up this really interesting conversation, but I feel like incentives actually isn't a problem that we see with researchers. If they can share their data, they will share their data, and we get so much data shared on these papers. I think the biggest problem is actually ownership of data in cohorts and consortiums, and now that it's so easy to collaborate across the world, you have different institutions collaborating, and then they write contracts on it saying, if someone else wants to use this, then there has to be co-authorship involved, and then there's all these other things that come into play because we have this world now where you can collaborate on this, but it's making it so difficult because they will not share their data and they will not make it public. And it's these new things that are coming on making it much more difficult to get them to make the data public in all fields.
Well, I guess I would just say that I think you brought this up, but I think the biggest thing to make this shift where data isn't being shared is funding agencies. I was on a panel this spring at Natural Science Foundation where we had some sort of extended conversations with program officers about this. And it's in communities where the communities decided that this is the standard. And then what happens is the peer reviews that are coming back on those proposals that are for an investigator who hasn't shared their data says this person's not sharing their data, it shouldn't be funded. And then the program officers will do that. So we started, there were a couple sort of proposals that we were funding, but we were just like getting the program officer to like stick in there, like we noticed you haven't like followed your data management plan, because people can write these data management plans and then not do them, and then NSF funds them again.
It makes me really happy to hear that you guys are actually, because I've been on several NSF panels and nobody cares. And so it's nice to hear that there might be some areas in NSF where they actually pay attention.
Yeah, and I think, but it's NSF, it's sort of the program officers responding a bit to the community too. But anyway, that's what, if we're thinking about what changes going to change behavior, the incentive of hundreds of thousands of dollars for the National Science Foundation is more than being able to see that there's been 70 page views on your specific data set to give it a list.
Yeah, I really like this point because there was a recent PLOS One article comparing a kind of survey of researcher perceptions of data sharing practices and such on. And it showed that people are now supporting data sharing more than they had in the past, but they're realizing the complexities and the obstacles. I just came back from a conference or a project launch down at UC San Diego of the Pacific Research Platform, which is a big NSF funded Pacific Coast effort to pull together all the big computing centers, San Diego Supercomputing Center and these places, into all the kind of high-speed network efforts and big data storage centers. And yesterday was a full day of science use cases, and it was such fascinating examples where the collaborations in research now are so huge that in a sense the data are immediately open. So if you think about something like pulling huge data sets from a telescope that is looking for these night-to-night changes to see if there's a supernova or a possible supernova. And then as soon as there's a signal there that might be of interest to people, to other researchers, it's being broadcast globally to every astronomical research group around the globe so that they can then, if they're interested in that particular signal, turn their instruments to that particular event in the sky, and then possibly go back and look at previous night's data and all of this kind of thing. But what it brings up to me is, well, does that mean there are multiple kinds of open? Because now they still have very specific rules that they've had to figure out. How do I share this within my increasingly global group of astronomical researchers? And I don't know if they're actually then sharing that with say, the public, or if it's still within just a very large community. So it's kind of open, but is that okay?
Sorry, Raymond.
Go ahead.
Oh, is it ever possible to get what's promised in the data management plans publicly released? So
Well,
that
NSF won't. Well, no, the NSF, if they're funded,
if they're funded, I'm just
yeah.
interested.
It's publicly released, because
No, they aren't public.
Yeah, the
it's
proposals
just
are
a
not
technical
publicly
and
released.
public
Yeah.
summary.
But the promise about, the public release plans.
There was
Can you get audit, like we have a public audit of it?
There was supposed to be NSF was doing a survey and going to summarize what they found in the data management plans, but that never came out.
No, it was an internal only document because they were looking across both funded and unfunded proposals, and so it was considered proprietary. Oh, it's 15-1504 says mine. So
Yeah, sorry guys. That's a big conversation.
Can I ask one last question? It's
Yeah.
raising
Yeah,
hands.
I mean, everyone's coming back in here anyways, so.
For how many people have you encountered money is actually an obstacle to data sharing? They don't want to pay the dryad fee or?
Well,
Yes?
we see that a little bit at LAUC, but I mean, just the scale you can run into those issues with researchers not having money.
That would-
Yeah.
Mhm.
Great,
All
thank
right.